Today's video is on writing and graphing inequalities. Students are very familiar with equations, but inequalities are very similar in the way that they're shown and the way they're solved. An equation is an algebraic sentence that contains the equal symbol. An inequality is an algebraic sentence that contains one of these 5 symbols. Now, students are familiar with equations and know that when that equal sign is placed, it shows that the two expressions are equal. What an inequality does is it compares two items that may or may not be equal. So the first inequality we're going to take a look at is the not equal to symbol. And this would be read as x is not equal to 7. This symbol makes a lot of sense because it's clearly an equal sign that has been canceled, showing that it's not equal to 7. Again, it would be read as x is not equal to 7. This next one is one that should be familiar to you, less than. And we know that less than, when you read that, you don't just say a less than 40, because as we learned in our expressions unit, that would actually mean 40 minus a. Instead, the way you'd read this is a is less than 40. And that indicates the value of a would be smaller than 40. Its partner would be greater than, and this symbol right here shows w is greater than 13. Again, not w greater than 13. That would indicate addition, but what we're trying to do is write it as an inequality. We'll use the word is. W is greater than. You'll recall the word is usually means equal, so that should be your hint to let you know that that's an inequality. Now here's another one of our new symbols for you, the less than or equal to symbol. And this we've really got to take a moment and think about. First off, the way we'd read it is b is less than or equal to 15. That symbol makes a lot of sense because it's clearly a combination of the less than sign and one of the lines and an equal sign, indicating that it could be less than or equal to 15. But let's be clear, it's different than the less than sign because b in this case could equal something less than 15 or it could equal 15. So our solution set is increased by 1. There's one more number that could be a value that could be a value of b. Same thing works with the greater than or equal sign, and this will be read as m is greater than or equal to 5. Now, those are the proper ways of reading these 4 symbols, but we need to understand that as we look at this, that there are more than one way we can read this symbol. You might also hear the phrase is fewer than. Again, you'll notice every single one of these starts with the word is, which indicates you're dealing with an inequality or an equal when you hear the word is. But when it says is at most, is more than, is no more than, is no less than, some of those can be a little bit confusing. So what I like to do is put it in a real life scenario. You know, if I say I have at least $40, well, I can use that to relate to real life and determine what that symbol means. But we're going to try a couple of these. I'm going to leave this up on the screen, and let's take a look at this first phrase. It says a number x is less than negative 2. All right, so I'm going to write my phrase out, and I know x, negative 2 are my terms, and then I'm going to realize is less than. Now, is less than, I'm going to find right here, it's just the less than symbol. So x is less than negative 2. Nice and simple procedure there. Here, this one's going to be a little bit trickier for 2 reasons. One, you're going to note that on one side of our inequality, we have a number m plus 3. And then we have is at most, and then 9 or other term. So on one side of our inequality, a number m plus 3. The other side of the inequality is 9. But now we've got a phrase that is not familiar to us. And that phrase is at most. We'll see it right here. Indicates that it's less than or equal to. But again, I just used the example is at least to help me have a connection there. Clearly is at most would be the opposite of that. So we want to use what we know so we can do these kinds of examples. I'm just going to darken up this because my pen is clearly running out of ink, just so you can very clearly see the answer we have here. M plus 3 is less than or equal to 9. All right? And so I have another example here. And again, we've got a combination of things. We've got a phrase, 5 times the number y, that's our expression. We have is less than, that will be our inequality, and 50. So again, 5 times the number y, we're multiplying 5 times y. We're going to write that as a coefficient on this side of my inequality. And then 50 will be on the other side of my inequality. And is less than would indicate less than. So that's my inequality. 5 times the number y is less than 50. All right? Now, we should be aware that a solution of an inequality is a value that makes the inequality true. So we're looking for a solution that would say it's true. Now, that doesn't mean it's equal. It doesn't mean it's balanced. It just means it's a true statement. So with an inequality, there are many numbers that could make the inequality true. So you should know that an inequality can have more than one solution, and we call the set of all solutions a solution set, which makes a lot of sense. What we're going to do right here is determine, hey, is 5 part of the solution set? So let's take a look at this inequality. It says x plus 4 is less than 14. So to see if 5 could be a solution to this inequality, we're just going to rewrite the inequality. 5 plus 4 is less than 14. That's a true statement because 9 is less than 14. So yes, 5 is a solution to that inequality. Now let's check a look at this inequality. Let's check and replace the b with a 5. And 9 minus 5 is greater than or equal to 6. Well, 9 minus 5 equals 4. Is 4 greater than or equal to 6? No, it's not. So just like we had done the not equal to, you could have not greater than or equal to, because it's not. This does not make this inequality true, and therefore, no, this is not a solution for this inequality. Now, if you wanted to graph x equals 7 on a number line, this is what it would look like. So that makes a lot of sense. We've done that before. It clearly shows the value of x is 7, and there's no other value of x other than 7. All right? So when we look at this number line, you can see that arrow means something. And what that indicates to us is that x could be 7 or something less than 7. So the inequality I'm actually looking here is x is, well, it could be equal to 7, or x could be less than 7. So the way we'd write this is x is less than or equal to 7. That solid dot matters because it indicates to us that, that it could equal 7. Now, curious as to why this one has an open circle. And that indicates that it does not equal 9. So when I look at this problem, I would say, well, x could be greater than 9. But x is not equal to 9. So the way I want to write that is x is simply greater than 9. The graph shows it's just bigger than 9. What I don't want to do is like it's greater than or equal to 10, because I got to remember that there are lots of numbers in here. 9 and a half, 9 and 1/4, that 9 could equal. So by doing the x is greater than 9, I don't need to indicate that it's not equal to 9 because I know it's got to be bigger than 9. 9 would not be a correct answer. So here are some tips, and you might want to jot this down. The graph of an inequality shows all the solutions of the inequality on a number line. An open circle is used when a number is not the solution. A closed circle is used when the number is a solution. And then an arrow to the left or right shows that the graph continues in that direction. So we're going to do a couple of examples here. It's a little bit small, so I'm going to kind of zoom in a little bit for you. It says x is less than negative 1. I'll actually write that a little bit bigger for you. X is less than negative 1. So I know that it's not negative 1. So I'm going to put an open circle on negative 1. And then x would be numbers less than negative 1. So let me think of a number that's smaller than negative 1. Well, negative 3 is less than negative 1. Negative 7 is less than negative 1. I'm going to point at all the items less than negative 1. Now, in this example, it says 2 is less than or equal to p. Now, this can be a little confusing because we're saying 2 is smaller than p. Okay? 2 is smaller than p. Smaller than or equal to p. So, well, or it could be less than or equal to. So here's 2, and it could be 2. But if 2 is smaller than P. A number that would make this true would be a number over here, right? 5. 2 is smaller than 5. So my arrow is going to point this way. Some people look at the less than symbol and be like, oh, well, I just going to point my arrow to the left. That only works if your variable comes first. Here, when my variable came second, my arrow pointed to the right. Some people like to kind of rewrite that where the variable would come first, but you clearly can't just change it like this, because that would tell a different story. So you understand that if you decide to flip the order, you actually would need to also flip your sign. And that would be another way to write an equivalent inequality. P is greater than or equal to 2, in which case the arrow would point to the right. Keep in mind, if the question is this, it's much better if you just take your time and figure out what this shows and select a number that the arrow is pointing to and make sure it makes that inequality true. The last example on this page, H is less than or equal to 7. So I know that it could be 7, so I'm going to shade that in. And then it's going to be smaller than 7. So 4 is less than 7. I can draw my arrow to the left because 4 I know is part of that solution set. By having the arrow and showing all the solutions, it's actually a big time saver because there are so many possible values that H could be. If I asked you to list all the values of H, you'd spend your whole life listing numbers because numbers go infinitely to the left, and every number smaller than or equal to 7 would be a solution to this inequality. The last thing I'd like to do is just recognize that we have some real-life scenarios where inequalities are used. And here are two that you're familiar with. A board game is designed for ages 6 and up. Well, our inequality would be clearly comparing X and 6. So how old do you have to be to play this game? Well, can you be 6 and play this game? Sure. Can you be 5 and play this game? No, the way it's designed, it should be ages 6 and higher. So that's going this way. So if it's ages 6 and up, that means X should be greater than or equal to 6. Well, it says you must be at least 5 feet tall to ride the roller coaster. At least. Some people look at this phrase and think, oh, at least that must mean smaller. But you know, if you want to be at least 5 feet tall, you've got to be at least either 5 feet or bigger than 5 feet. So this equation, or this inequality, would be X is greater than or equal to 5. So even though at least kind of makes you think of something being small, we've got to be really careful with that vocabulary. So just like the notes that I had suggested earlier about maybe jotting down, let's keep in mind these notes could be really helpful in remembering those phrases. So you'll have those in your notes in class, and if not, you could certainly copy them here to make sure you know all those key phrases. So thank you for sticking around for my video on inequalities, and we now know that an inequality is an algebraic sentence that contains the symbols not equal to, less than or equal to, greater than or equal to, less than, or greater than. Thanks for sticking around till the end.